In this video, you learn how to create an Excel model to calculate position size based on percent of account value, percent of equity at risk, or a combination of both those methods. Hello everyone, Jonathan here with Excel Help Now. Swing trading video for you today, looking at position sizing and how to do it. So I'll walk through the math of three different methods and why the final method is really the best way to approach your position sizing, especially if you're looking at multiple price targets. So I have pulled up on the screen here just a hypothetical example looking at AMC stock with entry price of $7.01 with a stop loss of 648, which is 53 cents of at-risk exposure per share. And we have a $25,000 account value with a max position size of 8% and then the max equity at risk percent of 2. And we want 4 price targets. So if we take a combination of all that information, we need to figure out how many shares to purchase. And then for each of these 4 price targets, how does that number of shares split out equally? So the first method you could do is just take the account value times your max position size that you want. So that would be 25,000 times 8%, and you would have $2,000 that you are going to purchase shares with in AMC stock. And so if you just round down function of C8, which would be our max position size, that $2,000 divided by the entry price, $7.01, you would have 285 shares. But we're trying to get number of price targets here of 4. So 285 divided by our price targets, you can see comes out to fractional shares. So we don't want that. So we've got to take that one step further and factor in our number of price targets to make sure that each of our price targets is equally weighted. So in order to do that, we'll do the same thing. We'll take C2, which is our account value, times our max position size. Then we're going to take that divided by our entry price, the $7.01. And then we take all of that in parentheses divided by C5, which is our number of price targets. And then we do the round down function to 0 decimal places. So it's a whole number to get to 71 per each price target. And then if we just take that 71 times our number of price targets, we get 284 shares. So one less share than the value we calculated above when we just took the 2,000 divided by the entry price. So that's how to calculate price target percentage of account value method with multiple price targets. We could change this to 3, and there the 285 that we calculated originally divided by 3 is an equal 95. We can make that 5, and then you can see it's still at 285. 6, it's down to 282. So it's dynamic. You set it up that way so you can have as many price targets as your trading method allows, but that's how to set up the math there. So that's a max position value. So that basically treats every position, regardless of the share price, as the same. So if this would have been Apple and you're looking at a share price closer to 200, then you're only going to purchase a couple shares and it's still going to be that 2000. The second method we could look at is thinking about it from a risk perspective, not looking at it from how much dollars we're committing, but how much risk we're putting on the table with this trade. So in order to calculate that, you'll take your account value, the 25,000 times the max equity at risk. And so that would be $500 we're willing to risk on this trade. And so to get the number of shares, you would take the max equity at risk value, that $500, divided by how much per share you're going to risk. So in this case, it's 53 cents, which is just the difference between your entry price and your initial stop loss. So 53 cents, which is the $7.01 minus our stop loss value of 648. So that gets us to 943 shares, which is much greater than the first method. And again, we have to look at that from a number of price targets. So 943 divided by 4, you can see that we have fractional shares. So we've got to convert that to equal number of shares. And in order to do that, it's similar to what we did above, where we're going to take C2, the account value, times C4, which is our max equity at risk percent. And then we're going to divide that by the entry price minus the stop loss value, or you could reference the at-risk amount per share. It's the same numbers. So F3 minus F4, all that in parentheses divided by the number of price targets. And then you'll use the round down function again to make sure that you get a whole value there. And we're left with 235 shares. And we multiply that by 4 to get 940 of total number of equal shares. And then we can do 940 divided by 4. So that'd be 235 equal shares that we purchase in order to max out our equity at risk. And so pretty big differences as far as the share count, 284 versus the 940. So if you're looking at this and want to keep each one of your positions basically equally weighted, you really need to combine these two. You need to consider both the max position value, the max amount of capital you're willing to commit, and also the max amount of equity you're willing to risk on a position. So in order to do that, you have to combine the two. And so I have referenced down here just our 2000 and our 500 above. So we've got to look at both a position size value and an equity at risk value, and then figure out what the share count is that is the minimum of those two. And so in order to combine that all together, we use an if statement. So what I have here referenced is if C19 is times F3 is greater than C24, then we're going to choose the percent of account value, the 284 shares. Otherwise, we'll take the C19, so the equity at risk account value. So you can see that based on the minimum here, 284 is less than 940. So that's what we'll go with, because we saw with the 940, if you take that times the number of shares, you get a position size of $6,589.40, which is way above our 2000 threshold. So that is how to calculate which, factor in both the percent of equity that you're willing to commit and then the max amount of equity at risk. You have to do an if statement to look at both of them. And then I have here of just what the position size would look like. 284 times our entry price gets us to $1,990.84, which is below our 2000. And then the equity at risk amount, which would be the 284 times the at risk dollar amount per share of 53 cents, gets us to $150.52. So that's below our $500 threshold. So that's how to, combine two different position size method to what I would consider the optimal amount that looks at how much you're willing to commit and how much equity you're willing to risk. And we can play around with this and say that instead of 2%, maybe we want to go down to just 1% and see if that changes anything. You can see that brings the number of shares down to 468. But let's say we want a wider stop here. Instead of 648, maybe you want that to be 597, so $1.04. And then here we can see that it flipped now. Instead of the $2,000 position size being our limiting factor, now it's this $250 equity at risk amount, which equates to 240 equal shares. So you can see now the calculation of the combination of those two. We need to go with 240 shares, which gets us to only $1,682 of equity committed versus the 2000 threshold. But that basically maxes out our $250 value here. We're at $249.60. We could change that to 3 price targets. Doesn't change anything. You can see the number of equal shares shifted on option 1. So hopefully you found this helpful. I do have a model that does all of this calculation for you, where you can factor in the account value, position size, equity at risk, number of price targets, and then you can also set your profit targets for each one of those price targets and the weighting to be able to find out your combined reward to risk ratio and your break even win percentage. I have a separate video where I went over the math behind that. So I do have this available for anyone interested, link in the description. Otherwise, hope you found this helpful. Consider liking and subscribing, and thank you and God bless.